Hello, I'm Neil, and in this video we're going to talk about cloud workloads. In the last video I talked about what the cloud did and how it's useful, and in this video I'll go through a little bit more in detail about the type of workloads that work well for the cloud and some of the workloads that don't work so well for the cloud. So let's get into it. Cloud workloads. What are they? Well, they can be websites, be it extranet or intranet, a sales page or something like that. Landing pages, marketing. We can run enterprise software in the cloud, something to do your business reports in. We can run data intelligence, data warehouses, analytics, all that sort of thing. Works well for cloud-based workloads. But all of these share a common designed for cloud principle. This video is part of a series based on my book, which is available on Amazon now. And if you want to look at the rest of the series, there's a playlist around here somewhere. Subscribe for more updates. Websites come in all shapes and sizes. I've displayed a few logos of the common frameworks here, be it Spring Framework or Laravel, and the things that these share in common is they're not static websites. They're often three-tier websites with a front-end layer, a business layer, and a database layer. These work well in a cloud environment because it enables us to scale each individual layer, or if you're going down a microservices route, you can scale individual microservices that make up each layer. This allows us to provide the exact quality and quantity of control around our website so we can serve the requests as best we can, but without having to pay for them all the time. We use the cloud flexibility to scale up during busy periods and scale down again during quiet periods. Enterprise software is usually deployed in a data center if you're a large enough organization, or in a local office on a server. This is because the data required is always local. It's not public internet data like shopping cart sales or anything like that. It might be internal invoices or things. So where does the cloud come in? Cloud gives us the flexibility to scale up and scale down. This makes it ideal for batch operations. If you're moving your data to the cloud, then that's got a cost to it. You then need to store it there. That's also got a cost. The trade-off is that we can throw a lot of resources at it. You don't want to run your reports off of your live database if it's running on the back of a shopping cart software, because that'll have an impact on the people using that shopping cart. As a general rule, when running reports, they should run off of the backup database, not the live database, to avoid that impact. However, if you've got the data in a certain place, then you want to run your reporting tools against it. Depending on the analytics and stuff, and we'll get to more of that in a moment, will depend on how much horsepower or compute you need in order to generate those reports. If you've got a lot of data, for instance, then it can take hours to report. And by that time, your data is now getting out of date and starting to creep away from you. By running the reporting in the cloud, it means we can enlist the support of lots of compute power and get those reports done as quickly as possible, either to reduce the impact on the database, make sure the data is fresh enough, or, given a larger data set, just to get the batch done in time ready for the morning. For bigger workloads and more data, you might have a data warehouse, stored in Hadoop or HDFS or something like that. And again, we can use the power of the cloud to scale up our resources to analyze that data. We want to get those reports as quickly as possible, and the more complicated systems get and the more data you've got, the longer those reports will take to run. On the opposite side of that, we can use more compute power to scale up. So instead of having 2 agents crunching the data, we can have 20 agents crunching the data. This means that the reports will be finished 10 times quicker. If you weren't hosting this data and the reporting agents in the cloud, we wouldn't be able to do that. So when running the reports, they would take longer. Machine learning and data classification takes up 2 types of resources. Lots of space to store the data, and lots of compute in order to train the neural network. We can use cloud resources to help us with both of these. With the scalability of storage space, we can transfer the data into the cloud, ready for our scaled up cluster to analyze and train on it. Once our neural net is trained, we can then transfer it back to the warehouse or the data center where it can actually perform the data classification on the data we have. As that's a rather static thing, we can leave that in place in the data center. using our existing resources. Training a network is quite intensive, and therefore it's useful to have the scaled up resources available that the cloud gives. So as you can see, the question I asked in the last video, do you have a data center, features quite a lot in the decisions here. If you don't have a data center, then obviously we would use the cloud all the time. And in that case, we would scale down the resources to the absolute minimum when we're not using them. You don't want to pay for something you're not using. But the other workloads I've described in this video, like the websites, we can scale up and scale down based on demand. We can run enterprise software, which enables us to scale up when we're running reports and scale back down again. And we got artificial intelligence workloads, where we can again scale up the data, where we're bringing it in from different resources to put it in together one place to analyze, and then use our agents scaled up to crunch that data. In the next video, I'll describe the principles that we use to design a cloud-based application so that we can utilize all the benefits of the cloud without having to pay too much for it. If you want notification of when that comes out, click on the subscribe button. I'll see you in the next video.